Hi friends, today I'm training on Coding Meetup number 9, Higher Order Function Series, is the meetup age diverse. And today we have a level 6 kata, and basically it asks you to search through the list and make sure that every age group, like teens, 20s, 30s, and so on, up until people older than 100 years old, all these age groups have to be represented. So first of all, it's really not easy for a level 6 kata. Maybe it might be, even, like, in my opinion, should be probably level 5, but still, let's try to tackle it. Let's see how functional can we get, and also always a challenge, can we solve it in one line? So let me first of all move to the tests, right? And to get in the mood, as I always like to do that, I am importing my expect, and I require it from the chai insertion library. Okay, then I, as always, rename my vars to be consts, and I'm ready to create my describe statement. So I describe, this time is age diverse. Yep, that's the name of the function. And let's see. First of all, it should work with list 1, right? And this one basically has to return true. So I expect is age diverse given list 1 to be true, right? Because look, 19, 29, 39, 40, 50, 60, 70, 80, 90, and over 100. So all the age groups are represented. Second one, it works with list 2. This time it is, I expect that to be false, so is age diverse list 2 to be false, right? Why so? Look, just 29 and 32, that's very easy. And basically, list 3, I will be lazy this time, I'm just copying it, making sure that's list 3. And it's also false. That's obviously false because there are only 4 items in the list. There has to be at least 10 items. So now that we have our tests ready, let's move to the main solution section. And to be honest, this time I really had to think about it, how to solve this kata, right? And just admittedly, I tried to solve it before, done that, and now just recording the solution. So first of all, of course, const is age diverse. I get a list. So what do we do? First of all, my idea is, look, so we have to make sure that there are at least 10 values, right? And these values have to be like first in the range from like 10 till 20, then 20 to 30, and so on and so on. But if we actually would divide that by 10 and like floor it, so that would very nicely go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? All these age groups have to be represented, except maybe for 10, But that's a special case. We can deal with this like special case when it comes. So my initial idea is, look, we can create an array, and we can have this array to have 10 elements. So we do that by using this syntax. If that looks hacky to you, you might consider that to be hacky. What it does, it creates an array of 10 items, and all of those 10 items are going to be undefined, right? So we have 10 items. We can check against them. My second idea is we should probably check that every single one of them returns true, right? So not reduce, every again. So every function, and this function, this time we are going to use not one, but we are going to use two arguments, v and I, and we are not actually going to use v. So some people, what we do, and that was a convention, I think, we use underscore as to indicate that this one is not used. So we can try this convention. Of course, be careful if you're using underscore or low dash. This will mess you up a little bit, but we are not using that in this case, so don't worry too much about it. Just in this case. In other cases, worry about it a lot. So we have every single number. We are getting every single number from 0 till 9, because that's the index. And basically we have to find if there is a corresponding, like a bit mapped corresponding item in this list, right? So what do? Is we do list find. Okay, that's how you find things in the list. And I only care about the age property, right? So I'm only pulling out the age. And I basically do this check, math.floor, right? Because we are flooring this, this, I don't know how to, this operation, this number operation, and we want to make sure that this I plus 1. So what's going on right here? Age is going to be like everywhere from like 10, 10, 20, 30, 40, 29, so on, so on. If you divide 29 by 10, you got 2.9, you floor it, you got 2. So that's the second I plus 2. So that's, you know, the first group is like from 0 till 10, so from 10 till 20, so that's the I plus 1, to be honest. The second group is like, again, the second I, as I goes from 0 till 9, so you got all these things covered. However, it's not that easy. What happens if a person is like 199 years old, right? So in this special case, and we only care for this case if I is equal to 9, right? We only care for this case if I is equal to 9. In this special case, we must make sure that age is equal or greater than 100. And in all other cases, this one will do the trick. So again, going from the beginning, creating 10 elements, 10 undefined values in an array. Every single one of them should return true. We don't care about 10 of undefined, so we are skipping this argument, just naming it underscore. We care about the index, and this index, we are using this index as a substitute, and we find if we can find this index plus 1 in the age group, but to group the age, not have like 29, we group the ages by just flooring them divided by 10. So I am like pretty sure that works. So I tried it, and ta-da, that works. So great. I really hope that you liked this kata, and I used a lot of tricks right here, right? Used a lot of tricks, but managed to solve it like in one line. That's saying that this kata is not like super hard. If you would go to like try level 4 katas, oh my god, some of them are like takes you the million of lines to solve, and they are like very hard, at least for me, some of them. But still, I hope that you liked it, and see you in the next kata. Bye, friends.